Good morning, Year 11. This is a lesson just to help you with a bit of review from some of the bits that we looked at yesterday, to talk you through a couple of things before you complete the set My Maths tasks on averages and scatter diagrams for today's lesson. As you can see, there's two Do It Now questions on the screen. I will pause for a moment to let you have a look at these. So pause the video, have a go at these for yourselves, and then now I'm going to go through the answers. So the first one, we write two multiples of 7 between 30 and 50. So we need to have two multiples of 7. So start off, if we write out the multiples of 7, you can see that we have 7, 14, 21, 28, 35, 42, and 49. From that list, 35, 42, and 49 are all between 30 and 50. So any two of those numbers, 35 and 42, 35 and 49, or 42 and 49 would be correct answers. For question B, you're asked to work out 40% of 140. So a good place to start without a calculator. 10% of 140 is 14. We do 140 divided by 10 to get 14. And then we want 40%, so it's 4 times as much as that. 14 times 4 would be 56. You might need to use column method or grid multiplication to get your answer on that one. So with this lesson, we are looking at averages and scatter diagrams. As you can see, our big picture here is still revising for the end of year 11 assessments. As I said in the live lesson yesterday, we don't know for sure what the grading is going to look like, how that's going to work for you with your GCSEs. But we will need to provide an accurate assessment of what you would get. And there will likely be for maths some exams to go with that, whether they're ones we get from outside the school or we set inside the school. But we will need to use those to help decide what grade that you get, and so we need to make sure you're best prepared for those. So we can carry on with sort of the revision we were looking at yesterday with averages and scatter diagrams. So I'm going to go through a few things, and like I said, there's some My Maths tasks set for you to complete as the main bit of your work that you will need to provide. So yeah, this will act as a bit more sort of revision. You can see there's a work star task at the bottom. If you complete that, then I will stick on a load more extra credits for you, as it's showing that you are taking risks, you're going above and beyond what you are needing to do. So there's 3 types of average that you need to be able to calculate. Can you remember the 3 types of average? Can you remember how to calculate them? There is a video link there. If I manage to work some YouTube magic, it'll automatically appear as a clip on the screen. We'll see how good my YouTube magic is. But that will there give you a reminder of different types of average, but we're going to go through them on this PowerPoint as well. So we got our 3 types. The mean is the one that people tend to think of when they're looking at average. You calculate the mean by adding the numbers together and dividing by the number of values. People tend to remember it well by going, oh, it's the mean one because it's the one where you have to do the most calculations. And it is, yeah, I mean, of the 3, it is probably the one that takes the most calculating to get an answer for. The second one is the median. And remember, you calculate the median by putting the values in order and finding the value in the middle. That's the one we particularly looked at with yesterday's lesson. And then there's the mode, and the mode is the value that appears most often. They've got that alliteration at the start, mode, most. They have that same sound at the start, which is a good way to help remember them. So some of those averages are more meaningful than others depending on the context. So if we think, what's the average number of ears in the world human population? Well, the mode represents the most common value. The modal value, nodal number of ears will be 2, because most people have 2 ears. The median represents the middle number. Middle value, if we put everyone's numbers of ears, we'd have a few people at the bottom who've got 0 or 1. And then there's after that very small number, the middle number included will be 2. So the median number is 2. And then the mean takes into account everything that we've got. So we add up the values and divide by the number of values. So the mean number of ears per person is 1.99999. Because, well, most people have 2. That the very few people who have 0 or 1 will cause that average, that mean, to end up being less than 2. So here, actually, the mode or the mean would be the best value to use. That's the most meaningful. That's why we have different types of average. Okay, most people tend to think of the mean when they're talking of average, but having those other types helps us when we get situations like this. So the mode is a good average if we have a limited number of different things. So like red, red, green, blue, the mode is red. If we've only got a few number of different things, so maybe 4 or 5 different things it could be, the mode is really good. The median is really good if we have very big or very small values. And it helps us see if something's in the top half or the bottom half, top 50% or bottom 50%. And the mean is the best average to use if we want to take all the values into account. So here we've got salaries of people in the room. 13,000, 18,000, 24,000, 25,500, 26,000, 32,000, 45,000, and 1,200,000. Well, if we look at the different types of average, all of those values are different. There's lots of different values. It's not a limited number of different things. There's lots of different things. So the mode isn't going to be useful here. The median will help us to see what's in the middle. So that could actually be quite useful. The mean takes into account all the values, but we've got that 1.2 million here. That would drag that mean up. The mean, if we work this out, is going to be above 45,000. So if we worked out the mean, we'd be saying, oh, most people earn less than the average. In fact, everyone apart from that really, really, really high earner would earn less than the average. So that 1.2 million drags up our value for the mean, and therefore it isn't that useful. The median is the best one to use here. And our median comes in at 25,750, halfway between 20,000, 5,500 and 26,000. So that's where it's good to use different ones. There's one on the board there. I'm just going to leave that up. I suggest you pause the video, have a go at working out that one to work out the mean, median, and mode for these. So to go through the answer, the mode, the one that appears the most, 17. There's 2 17s, every other number only appears once. The median is 16. It's the number in the middle. We've got cross off the 10 and the 20, cross off the 17 and the 13, cross off the 15 and the 17, leaves you with 16 in the middle. And the mean, you add them all together, divide it by 7. The mean here comes in at 15.43. Now, if we haven't got any information about the data, if we can't see that anything's bigger or lower than the others, any one of these averages could do, and we tend to go default to using the mean. Use that one as the one that people most often expect us to use. So, another one for you to practice, and you'll see I've put the range in at the bottom, a bit of a throwback to yesterday's lesson to just remind you of getting the mode. Pause for a moment, let you have a go at that. Right, and so the mode, it's 13. The median is 15. So when there's 2 numbers in the middle, we use the value between them. Remember yesterday we saw 2 ways of doing that. We could do 13 plus 17 to get 30 and divide it by 2 to get 15. Or we could do 17 minus 13 as 4. Half of 4 is 2, and then 13 plus 2 would be 15. You can then check it by going, oh, 15 plus 2 would be 17. So yeah, it's halfway between them. The mean, you add them together, divide it by 4, you get 15.75. And then finally, we get the range. And the range is the difference between the smallest and the largest. So you do the largest number, you take away the smallest, you get the range. So here that's 7. The range isn't an average. Okay, mode, median, and mean give you averages. They tell you roughly what you might expect from the data, a typical value you might get from the data, or generally what's happening. The range just tells you how spread out it is. So this tells you that there's a difference between the biggest and smallest is 7. It's quite low, especially when our mode, median, and mean are all bigger than the range. Okay, so that's our look on averages. So that's our look on averages. We're now might be a good chance to do the My Maths task on the averages work, and then come back to this video and look at the work on scatter diagrams. That's what we're going to look at now, scatter diagrams. We used them yesterday, focusing on correlation, and we're just going to remind ourselves, scatter diagrams display data involving 2 variables, 2 bits of information, about certain things. So this one collects data comparing students' test performances in English and maths. So each of these points, that person there scored 40 in English and 55 in maths. So you can see there, that point in the middle there, that's where it's 40 for English and 55 for maths. 65 for English and 57 for maths. Go along to 65 for English. 57 would be that point there. Each one of these points represents a different person. Now you'll see here on the diagram, because it's used from Excel, they use little diamond points, little rotated squares actually, to be specific. When we write this on paper, we tend to use little crosses to indicate the points. Now, scatter diagrams are really useful because they help us identify a relationship between two variables here. That relationship between two variables is known as correlation. So correlation tells us about the relationship between two variables. So here, English and maths test scores are related. Someone's English test score is higher, their maths score tends to be higher. Now, this is only for this information. This isn't going to be true for absolutely everyone. You can see there's certain people, this person up here only scored 40, just over 40 in English, but scored over 90 in maths. So they're probably someone who is a lot more confident at doing their maths work than maybe their English. And it doesn't mean that everyone will have this. It says the score tends to be higher. So we'd expect it to be higher, but it won't always be the case. And we call this relationship positive correlation. Because one value goes up, the other one goes up. The points are generally increasing as we go from left to right. Now this here, this error is a typical one that people make. A higher English score means their math score will be higher. That isn't always the case. Remember, it tends to be, it's what we expect, but it doesn't mean it's going to happen for sure. Now there's different types of correlation, and sometimes we can refer to the strength of it. So here, this correlation is weak positive. It's generally going up, but we've got a few points that are quite scattered away from it. This one here would be weak negative. As the age increases, the time on the internet decreases. People have more responsibilities. Maybe they're less interested in using the internet. And it's, as one value goes up, the other goes down. The points are going down as you go from left to right. And it's weak because they're still quite spread out. The one on the bottom left here is strong positive. Distance traveled, cost of train fare, that increases. As you travel further, you pay more. The points go up from left to right. That's the positive. And it's strong because they're really close together. They're really almost on a perfect straight line. And this last one, number of people in the city called Dave compared to the crime rate. There's no correlation. If you have more people in the city called Dave, it doesn't mean the crime rate's going to be higher. Similarly, if there's fewer people, it doesn't mean the crime rate's going to be less. And they're the three types that you need to identify: positive, negative, and no correlation. Now, the last thing that we're going to look at with scatter diagrams is a line of best fit. You might have seen that I drew a line yesterday in yesterday's lessons and called it a line of best fit. And we use this to help us make predictions. So this line roughly goes through the middle of the data. It's got roughly the same number of points on each side, very roughly. And this would be the perfect line of best fit. But you can see it doesn't fit everything. It takes into account this outlier here, this person who got a low English score but a really high maths score. So because of that, we'd normally expect our line to go up more through the middle and sort of ignore that point as an outlier. But using this line, we can still say, okay, if a boy gets 50% in his English test, what score might you expect him to get in his maths test? So we go up to 50 on the English, and then we read across. It's somewhere around about 67 there. 65, you can 65 to 67. See that line? Because the line isn't drawn perfectly, because we haven't got a perfect scale there, those bits are roughly on the lines. Now, this is the last bit that we're going to sort of look at today. What you need to do now, if you haven't done so already, is go and do the averages tasks that have been set on My Maths, and then the scatter diagrams task. And so to do the scatter diagrams task now, you've done your revision there. Okay, you've I emailed out your MyMass passwords to you yesterday, so you should have those to be able to log in and access the tasks. But please send me an email, ma@warwick.surrey.sch.uk if you can't log on to your MyMass, and I'll be able to sort of help you out with that. Have a good day, everyone, and I'll see you for tomorrow's live lesson tomorrow afternoon. I hope you have a good day before then. Take care. Bye.